When you drop a heavy, solid bowling ball into a tank of water, it goes straight to the bottom every single time. But look at this massive hull. This ship is made of steel and weighs thousands of tons, yet it stays right on the surface. We need to find out why. Our mission today is to take a solid, heavy lump of clay and figure out how to make it float just like that ship. We're going to look past how heavy these objects feel and see how their materials and their shapes change the way they behave in the water. Imagine you're packing a suitcase. The measure of how much stuff is squeezed into a specific amount of space is what scientists call density. Look at these two spheres. They are the exact same size, taking up the same amount of room. But the bowling ball is packed tight with heavy material, giving it high density. The beach ball is mostly empty air, so it has very low density. This leads us to a rule. Objects with high density sink, and objects with low density float. If you try to force way too much stuff into that suitcase, the density gets too high, and the whole thing bursts. Since water has its own density, any object packed tighter than water will go down, and anything packed looser will stay up. Think about trying to shove a beach ball underwater at a swimming pool. The ball usually fights back and shoots right back up to the surface. That's because of an invisible upward push from the water called buoyancy. Gravity pulls down, but the water pushes back. It's spelled B-U-O-Y-A-N-C-Y. We pronounce it buoyancy. You can see this push in action at the Dead Sea. Its salt water is so dense, the strong buoyancy holds people up like corks. An object stays on top only when the water's upward buoyancy is stronger than the object's downward pull from gravity. Back to our clay. If we drop a solid ball of it into the water, the density is too high and it sinks immediately. But look what happens when we take that exact same clay and flatten it into a wide, hollow boat shape. Now it floats. This diagram shows the change. That boat shape traps air inside. The clay weighs the same, but it now takes up more space. This lowers the density of the whole boat, letting the water push it up. Giant steel ships follow this same logic. Even though they are made of heavy metal, they are designed to be hollow inside, just like our clay boat. This is the Pioneering Spirit, the world's largest ship. Its hollow design keeps its total density lower than the water it sits in. It is so massive that it weighs as much as 370 Eiffel Towers, yet it still floats effortlessly. This reveals that shape is the variable that matters most. It's how we control the density of even the heaviest objects to keep them on top of the waves. Time to put your brain to the test with the Junior Explorer Challenge. First question. What do we call the invisible upward push of the water? If you said buoyancy, you got it. Question 2. Which object has more stuff packed inside, a bowling ball or a beach ball? The bowling ball. That's why it's denser. Great work. To join us on our next scientific adventure, hit that subscribe button right now. Quick recap. 1. Density is how tightly stuff is packed into a space. 2. Buoyancy is the water pushing back up. And 3, changing an object's shape allows us to change its density. Now, try this at home. Build a clay boat and see how many pennies it holds before getting too dense to float. So density decides what we see floating on the water. But there are invisible waves in the air you can actually hear. Tap right here to see how they work.